The objective of this practical is to identify forward biased and reverse biased operating characteristics of diode. Now as you can see here, we have a diode, and how you are going to identify the anode and cathode of diode. As you can see here, we have a fine line, silver line, and this fine line is representing cathode, whereas we don't have any line here. It means this terminal of diode is anode. Okay, so this is how you are going to identify terminals of diode. Now, in order to identify forward biased operating characteristics of diode, we will build this circuit on breadboard. As you can see here, positive terminal of battery is connected to anode, and the cathode of diode is connected in series with load resistor, which is of 10 kilo ohms. Okay, then after building this circuit on breadboard, we will measure voltage across diode and current through diode. In order to measure voltage, voltmeter is going to be connected in parallel to this diode, and for measuring current, ammeter will be connected in series with diode, as you can see here. So how we are going to build this circuit on a breadboard? Now as you can see here, I have connected this diode randomly on breadboard. Now I am going to connect load resistor of 10 kilo ohms in series with this diode. Now as you can see here, I have connected load resistor in series with this diode. Now I am going to connect positive and negative terminals of supply voltage here. As you can see in this circuit diagram, positive terminal of supply voltage is connected to anode, negative terminal is connected to second terminal of load resistor. So here I have connected this positive and negative terminal of supply voltage here on this breadboard. How? I have connected positive terminal of supply voltage to anode of diode, and negative terminal of supply voltage is connected to second end of resistor. Okay. Now in order to measure voltage across diode, I'm going to connect this multimeter in parallel to diode. As you can see here, I have set this voltage range, and here I have connected this black probe to COM socket, and red probe is connected to volts, ohms, hertz and diode socket. Now here as you can see, I have connected these red and black probes to the circuit. How? I have connected them in parallel to this diode. Now I am going to give supply voltage to this circuit, and then I'm going to measure voltage across this diode. Now as you can see here, supply voltage is 2.4 volts, and here the voltage across this diode is 0.5 volts. Now when supply voltage is increased to 3.9 volts, the voltage across diode is 0.53 volts. Now I have further increased this supply voltage to 5.3 volts, and now the voltage across diode is 0.55 volts. So this is how you are going to measure voltage across diode, by increasing supply voltage. Now for measuring current through diode, I'm going to use this multimeter. Now as you can see here, I have set this knob to current range, and here I have connected black probe to COM socket, and now red probe is connected to milliamperes socket. Okay. Now for measuring current, I have connected this multimeter in series with this diode, and now the circuit looks like this. Now I'm going to give supply voltage to this circuit, and then I'm going to measure current through this diode. Okay. Now after measuring voltage across diode and current through diode for different applied voltages, you are going to fill this observation table. It means what values of voltage and current you are getting when applied voltage is 0.1 volts and when applied voltage is 0.2 volts, then what values of voltage and current you have. So you are going to write these values in this table. Now after that you are going to find dynamic resistance. Now how you are going to find dynamic resistance? You will select any two consecutive values of voltages from this table. Like here we have selected this value and this value of voltages across diode. So here change in voltage will be 0.55 minus 0.5 and it will give you 0.01 volts. Okay, now what about current? When voltage is 0.55 volts, current through diode is 1.4 milliamperes, and when voltage is 0.54 volts, then current through diode is 0.08 milliamperes. So the change in current will be this. Okay, now by applying Ohm's law you are going to find the value of dynamic resistance like this. Now you are going to plot the graph between current flowing through diode and voltage across diode like this. Then you will read this graph and you will find cut-in voltage from this graph. As you can see here, cut-in voltage is 0.3 volts because after that there is an increase in current flowing through diode. Okay, so these are the forward operating characteristics of diode. Now you are going to repeat this procedure for identifying reverse biased operating characteristics of diodes, and for this you will connect negative terminal of supply voltage to anode of diode. Okay, and positive terminal of supply voltage will be connected to second terminal of load resistor like this, and then again you are going to find current through this diode by connecting ammeter, that is multimeter, in series with this diode, and then you will find voltage across this diode by connecting voltmeter or multimeter in parallel to this diode, and then you will fill that observation table, and then you will find dynamic resistance, and then you will plot the graph between current and voltage, and then again you are going to read that plot. Okay, so this was your practical 7.